Most houses in the United States are built from wood. This is different from many other countries, where homes are made from brick, stone, or concrete. The reason goes back almost 200 years to a small but important change in the way builders put houses together. In the early 1800s, most homes in America were built using heavy timber frames. These frames used thick wooden beams, often as large as a foot across. Skilled carpenters had to cut deep notches into each beam so the pieces would lock together. This work took a long time. It also needed years of training to do well. A single house could take a full team of skilled workers many weeks to frame. In 1832, a carpenter in Chicago named George Snow built a warehouse using a new method. Instead of thick, heavy beams, he used thin, light strips of wood called studs. These studs ran straight from the bottom of the building to the top. Workers held them together with nails instead of hand-cut joints. A year later, in 1833, another builder named Augustine Taylor used the same method to build St. Mary's Catholic Church in Chicago. This church became one of the most famous early examples of the new style. At the time, some builders made fun of this method. They said the thin wooden frames looked too light and weak. They joked that a strong wind might carry the whole building away, like a balloon. That is how the method got its name, balloon framing. The name was meant as an insult, but the buildings turned out to be strong. Many balloon-framed structures from the 1800s are still standing today. Balloon framing spread quickly for a few clear reasons. First, it did not require highly trained carpenters. Two workers with basic tools could frame a house in days instead of weeks. Second, it used small, standard pieces of lumber instead of large custom-cut beams. This made the material easier to transport and store. Third, nails had recently become cheap and easy to produce in factories. Before this, nails were expensive and often made by hand. Cheap machine-made nails made it possible to hold a house together without deep notches or joints. Chicago was growing fast in the 1830s. Thousands of new settlers were arriving every year, and they all needed homes quickly. Balloon framing let builders keep up with that demand. A method built for speed and low cost turned out to be exactly what a fast-growing city needed. A farmer and writer from Indiana named Solon Robinson helped spread the idea further. He was one of the first people to write publicly about balloon framing and to recommend using nails throughout the entire frame instead of traditional joints. His writing reached builders in other towns who had never seen the method in person. Around the same time, companies began printing house plan pattern books. These books gave builders standard designs and material lists they could follow without hiring an architect. Some companies went further and sold pre-cut, ready-to-assemble house kits, shipping the pieces by rail to towns across the growing country. A method that started as one carpenter's shortcut in Chicago turned into a repeatable system that any builder could learn and any family could afford. This had a real effect on who could own a home. Before balloon framing, building a house from heavy timber often required hiring a team of skilled carpenters, which made home construction expensive and slow. Balloon framing lowered both the cost and the skill needed, which meant more working families could afford to build or buy a house of their own. In cities like Boston and other parts of New England, builders used a version of wood framing to construct three-story apartment buildings known as triple-deckers, giving working-class families an affordable place to live within walking distance of factory jobs. The timing mattered in another way, too. Railroads were expanding across the country during this same period. Trains could carry sawn lumber from forests in the Great Lakes region to cities and towns far away. At the same time, steam-powered sawmills were cutting logs into standard sizes much faster than workers could cut them by hand. Together, cheap nails, fast trains, and powered sawmills made wood framing cheaper than almost any other option. America also had something Europe did not have as much of by this time: large forests close to where people were building. Many parts of Europe had cut down most of their old forests centuries earlier for farmland, fuel, and shipbuilding. By the 1800s, wood was often scarce and expensive in parts of Europe. Brick and stone were more available there, so builders used those materials instead. In America, the opposite was true. Forests covered huge areas of the country, especially in the Northeast, the Great Lakes region, and later the Pacific Northwest and the South. Lumber was abundant and cheap, so it made sense to build with it. Cost was not the only factor, but it was a major one. Wood framing needed less labor than brick or stone construction. Brick buildings required skilled masons, and masonry work generally took longer per square foot than nailing together a wood frame. Wood was also lighter to transport than brick or stone, which mattered in a country that was still building roads and railways to reach new towns. For a nation expanding westward at a rapid pace, speed and low cost mattered more than the extra durability that brick could offer. Balloon framing was not perfect. Its long, open stud cavities ran from the floor of a building all the way to the roof without any breaks. In a fire, this created a hidden pathway for flames to travel quickly upward, hidden inside the walls. A fire that started in a basement could reach the attic before anyone even noticed. This was part of what made the Great Chicago Fire of 1871 spread so fast through the city's wooden buildings. Because of this fire risk, builders eventually changed the design. By the early 1900s, a newer method called platform framing became more common. Platform framing builds one floor at a time. Each floor becomes a solid platform before the next floor is built on top of it. This breaks up the open stud cavities and slows the spread of fire inside the walls. Platform framing also used shorter pieces of lumber, which were easier to produce and transport as forests near cities were used up and mills had to rely on younger, smaller trees. By the mid-1900s, platform framing had mostly replaced balloon framing across the country. It is still the standard method used to build most American homes today. After World War II, the demand for new houses grew enormously. Millions of soldiers were returning home and starting families, and the country needed a huge number of new homes very quickly. Builders like William Levitt became known for using standardized, factory-style methods to build entire neighborhoods of similar wood-framed houses in a short amount of time. These fast-built, affordable neighborhoods became the model for the American suburb. Wood framing was central to making that kind of large-scale, quick construction possible. Brick or concrete construction, by comparison, would have taken far longer and cost far more to build at that same scale and speed. Wood framing also fits well with the kind of climate and geography found across much of the United States. In areas with cold winters, wood-framed walls are easier to fill with insulation than solid brick or concrete walls. In areas prone to earthquakes, like parts of California, a wood frame can flex slightly during shaking without collapsing, while a heavier, more rigid material like unreinforced brick is more likely to crack or fail. Wood is also lighter than brick or concrete, which matters for foundations and for shipping materials to a building site. Another factor is flexibility after the house is built. Wood-framed walls are easier to open up, move, or remove than brick or concrete walls. This makes renovations, additions, and repairs simpler and less expensive. If a homeowner wants to add a room or change a layout, a wood-framed house is generally easier and cheaper to modify than a masonry one. Cost differences between wood and brick or concrete construction still exist today. Wood framing typically requires less specialized labor than masonry work, and the material itself is often cheaper to buy and transport, especially since large parts of the country are close to working timber forests. The United States has an established, large-scale lumber industry that supplies standardized, pre-cut lumber to builders everywhere. This industry grew directly out of the balloon framing era and has continued to expand for nearly 2 centuries. Because of this long history, most American carpenters, architects, and building codes are built around wood framing. Workers are trained in it, tools are designed for it, and local building departments are experienced in inspecting it. Switching to a different primary material on a national scale would mean retraining much of the construction workforce and changing many existing building codes. Wood is also considered a renewable resource. Trees used for construction lumber are typically grown on managed timberland and replanted after harvesting. This is different from materials like concrete, which requires mining and processing raw materials such as limestone and clay, or steel, which requires mining iron ore and using large amounts of energy to produce. Because of this, wood framing is often described as having a lower environmental impact per house compared to concrete or steel framing, as long as the forests supplying the lumber are managed responsibly. None of this means wood is the only material used in American homes. Many houses use brick, stone, or stucco on the outside, but under that outer layer, the structure holding the house up is usually still a wood frame. Full masonry construction, where the walls themselves are made of solid brick or stone, is much less common in the United States than it is in much of Europe. What looks like a brick house in America is often a wood-framed house with a layer of brick attached to the outside for appearance. The numbers today still show how strong that pattern is. According to the National Association of Home Builders, about 94% of new single-family homes completed in the United States in 2024 were wood-framed. Concrete-framed homes made up about 5%, and steel-framed homes made up less than 1%. This share has stayed above 90% for years, even as material costs have gone up and down. Out of roughly 1 million new single-family homes built in a typical recent year, close to 960,000 of them were built with a wood frame. Very few used concrete, and even fewer used steel. There are some regional differences. In parts of the South, especially in states that face strong hurricanes, more homes are built with concrete block or reinforced concrete than in the rest of the country. Florida is a clear example. High winds and flying debris during hurricanes can badly damage a wood-framed wall. So many builders there use concrete block for at least the outer walls, even though the roof structure is often still built with wood or engineered wood trusses. This shows that builders do choose stronger materials when local conditions call for it. Wood is not used everywhere for the same reasons. It is used where it offers the best balance of cost, speed, and performance for the local climate and risks. It is useful to compare this to how European building changed after a different disaster. In 1666, a large fire destroyed much of the city of London. Most buildings at the time were built with wood frames and covered in flammable materials, and the fire spread easily from building to building through narrow streets. After the fire, English law began requiring new buildings in London to be built from brick or stone instead of wood. Over time, this shifted much of English and European building culture toward masonry construction. By the time American colonists were building their own towns more than 100 years later, wood was still the default material in most of North America, while brick and stone had become the standard in much of Western Europe. Two different fires, in two different centuries, pushed two regions toward two different building traditions that are still visible today. Modern wood construction is also more advanced than it was in the 1800s. Builders today use engineered wood products, such as oriented strand board and laminated veneer lumber, alongside traditional dimensional lumber. These engineered products are manufactured to consistent strength standards, which makes them more predictable than a naturally grown piece of timber. Modern building codes also require wood-framed homes to meet specific standards for wind resistance, seismic performance, and fire safety, depending on where the home is located. A wood-framed house built today under current codes is a very different structure from a balloon-framed house built in the 1800s, even though both use the same basic material. Insurance also plays a role in how homes are built and priced today. In wildfire-prone areas of California and other western states, insurance companies have become much more careful about which homes they are willing to cover. Homes built with fire-resistant materials, defensible landscaping, and modern fire codes are generally easier and cheaper to insure than older wood homes without these features. This has pushed some newer construction toward fire-resistant designs, even while the underlying frame often remains wood. The material itself is not usually the single deciding factor in whether a home survives a fire. Design choices, roofing material, spacing between structures, and nearby vegetation all matter as much as, or more than, the frame underneath. So the short answer is this. American homes are built mostly from wood because of a combination of history, geography, and cost. Wide forests made lumber cheap and available. A new building method invented in Chicago in the 1830s made wood framing fast and simple to learn. Railroads and sawmills made lumber easy to move and cut at scale. And in the 2 centuries since, the entire construction industry, from training to tools to building codes, grew up around that same wood-framed system. Once a method becomes the standard across an entire industry, it tends to stay the standard because the workers, the codes, and the supply chains are all built around it. What began as one carpenter's fast, low-cost warehouse in 1832 grew into the building method behind nearly every American neighborhood built since. The forests were already there. The cheap nails and steam-powered sawmills arrived at the right moment. And a growing country needed homes built quickly, not slowly and expensively by hand. Almost 200 years later, The vast majority of American houses are still framed the same basic way.